Myself, Satish B. Thalange, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. In today's session, we are going to see the statistical quality control. In this session, the observer will be able to understand the concept and the importance of the statistical quality control with the overall the control charts and their types, and will be helpful for the application of the statistical quality control charts for the quality improvement. Let's start with the statistical quality control. It is a technique which is useful for the overall the observation of the, or you can say, the quality performance of the overall unit. The statistical quality control can be divided into three categories. Here, the first one is the descriptive statistic. Second one is the statistical processes control. Second one is statistical process control. Third one is acceptance sampling. Now let's see one to one. The descriptive statistics are used to describe the quality characteristics and its relationship. Here, the product have been observed with the various statistic observations such as the means, standard deviation, and the range. In the overall the first bit, the statistical process control answers the questions of whether the process is functioning correctly or no. Now the last one is the acceptance sampling. It is a process of the randomly selecting, or you can say inspecting the products and decide whether to accept the particular entire lot based upon the observation and its results. Acceptance sampling determines whether the batch of the product has to be accepted or has to be rejected. Let's see the descriptive statistic. The means, that is also known as the average, a statistic that measures the central tendency of the set of the data. And the range, the difference between the largest and the smallest observation of the particular set of the data. With the standard deviation is helpful for the overall measuring the amount of the dispersion of the data with the overall the mean. And finally, the average of the squared difference from the overall the mean will be helpful for to define the variance of the particular product or the lot. Now let's see the simple example of the descriptive type of the overall statistical quality control. Here there are a metal rod with the various particular length. The overall, if we observe, there are the 5 pieces which have been measured, out of which if we observe the first is of 100, second one is of 102, third one is of the 101, 99 and 103. The rods are of various length, and if we want to determine the mean of this, we have to take the average of all this, and we have to if we observe the value of the mean of this particular rod is 101 centimeter. And if we observe the range, it is, we have to see the highest value 103 and the lowest value it is a 99. The difference between this is of 4 centimeter. In this way, we can go with the defining the standard deviation as well as variance of the particular product of the lot. The statistical process control methods. The control chart. Basically, this particular section deals with the control chart. Here we go with the graphical presentation of the overall the product measurements in the terms of variability as well as attribute. These control charts are helpful for the finalizing, or you can say making a decision whether the particular product is within the range or no, whether to accept or whether we have to reject. Now, the types of the control charts. The types of the control charts are of two types, the variable control charts and the attribute control charts. Now, let's see what is the variable control chart. The variable control charts are the charts which are helpful for a product characteristic that can be measured and that have the range of the values. Examples related to the variable are like a height, we can measure the height, the weight, we can get the weight of the particular product or any unit, and the volume, etc. And the attribute is a overall the type of a chart which can go with the utilization for the products that have the characteristics that can be a discrete type of values that can be counted but they cannot be measured, as we do in the earlier one, that like we can measure the height, we can get the weight, we can get the volume, but here we can only count, or you can say the scratches on the glass and the number of complaints called from the customers, that can be just counted. Now let's see the control charts. The control charts of the variables. The first one is the X bar chart, or you can say X chart. The control chart used to monitor the changes in the mean value of the particular process. Let's see the example. Here it is the rod which are been overall measured. The length of the rod they are measuring daily, and they are defining the overall the mean of that particular, and it has been said that the overall, suppose they have measured 100 number of rods, we have to get the mean of that and we have to check whether they are within the range or no. For that, the example that is mentioned, that is 100 plus or minus 2 centimeter. Now the second chart is a range chart, or you can say R chart. It is used to control the charts that monitor the change in the range or the ability of the process. As we have seen the earlier example, we are measuring the length of the particular rod, and they are declaring that the mean as well as they are declaring the overall the range, that is 100 plus or minus 2 centimeter. Means we can accept this particular rod of the either of 102 centimeter or 98. So the range is from 98 to 102. Though this is the overall the R chart. If the rods are more than that, they are going to be rejected or they are going to be out. This is all about the variable chart. Now coming to the attribute chart. The P chart, a chart that monitor the proportion of the defects in the sample. For example, a company inspect 100 smartphones daily, and it has been recorded that the portion of defect of the screen. Here the P chart help us to define the defects portion, okay, with the overall the observations which are being done for the particular smartphone, and based on that the acceptancy limitations can be declared, that can be observed and that can be declared the counts. Now the C chart. A C chart is used to monitor the number of defects per unit, or you can say per lot also. Here example, the company which is a printing company, they have printed the books. Now while printing, there may be the chances of getting a misprinting of the words or the alphabets, the content which are within the books. So we can go with the count, the number of typos per books in the counts, or you can say overall the books, and we can declare the number of typos in the particular books per book, you can say. So we can have the monitor and we can control and we can declare the overall the defects. These are all about the attribute charts. Now let's answer the following questions. Which control chart is used to monitor the mean value of the process over time? These are the options. Which type of control chart is designing to measure, or you can say monitor, the variability or the dispersions of the process? These are the options. Now focus on the overall, the monitoring the variability or the dispersion of the process. So answers are as highlighted in this particular slide. So these are the references for today's session. Thank you.